Right now, 111 light years from where you're sitting, there's a world that, until very recently, no human being knew existed. No probe flew past it. No spacecraft ever will. We didn't find it by watching it dim a star. We found it because a telescope, for the first time ever, simply looked and saw it staring back. And what makes this one different from every planet before it is the part scientists almost didn't believe. For almost 30 years, we have known other planets are out there. Thousands of them. Nearly 6,000 confirmed. But here's the uncomfortable truth the headlines skip. We've barely seen any of them. Almost every alien world we've ever discovered was found in the dark, detected by a wobble or flicker, a shadow crossing a star. We knew they were there the way you know someone is standing behind a spotlight. You feel them. You can't see their face. For decades, seeing an alien world directly, actually pulling its light out of the blinding glare of its sun, was considered nearly impossible for small planets. And then, in a single image, that wall cracked. By the end of this video, you'll understand exactly why researchers called the first version of this a transformative moment for all of astronomy, and why the second version, the one from 2025, quietly rewrote what we thought this telescope was even capable of. Because this isn't just a pretty picture, it's the first step on the road to photographing another Earth. Before we go further, if you want the parts of this story the thumbnails never explain, the actual science under the spectacle, subscribe. This channel is where the real discoveries get unpacked first, before they get flattened into a headline. Now, to understand what just happened, we have to go back. Here's the problem that haunted astronomers for a generation. A star is not just brighter than the planets around it, it is violently brighter. Think of a firefly hovering next to a stadium floodlight from a mile away. The floodlight doesn't just outshine the firefly, it erases it, drowns it in glare. For a planet like the one this telescope photographed, that gap can be more than 10,000 to 1, 10,000 times fainter than the star sitting right next to it in the sky. So for years, we cheated. We found planets indirectly. The most successful trick is called the transit method. You stare at a star for weeks. If a planet crosses in front of it, the star dims, just a hair, less than 1%. Measure that dip and you can infer a planet you never actually saw. It works. It found thousands of worlds, but it has a ceiling. A transit tells you a planet is there. It doesn't hand you a photograph. You never see the world itself. To see one, to capture actual photons that bounced off or glowed from a distant world, you need a different weapon entirely. You need to kill the star. Not really, of course, but optically. You need a device called a coronagraph, a tiny, precisely shaped mask that sits inside the telescope and blocks the light of the star. And only the star, like holding your thumb up to hide the sun, do it right and the glare vanishes. And in the darkness where the star used to be, faint objects start to appear. For a long time, even that wasn't enough. The technique only worked on the biggest, brightest, angriest planets, super Jupiters, giant worlds several times the mass of Jupiter, still glowing red-hot from the heat of their own birth. So that's where we started. In September 2022, less than a year after it launched, the James Webb Space Telescope was pointed at a young star about 385 light-years away, and it captured its first ever direct image of a planet beyond our solar system. The world was called HIP 65426b, a gas giant, somewhere between 6 and 12 times the mass of Jupiter, cosmically newborn and only 15 to 20 million years old, when our own Earth is 4.5 billion. And it was faint, more than 10,000 times fainter than its star. The scientist who led the analysis described pulling the planet out of the data like digging for space treasure. At first, all he could see was the star's light. Only after careful processing did the world appear. It was small, fuzzy, just a smudge of infrared light and 4 filters, and it was one of the most important pictures this telescope had ever taken. But here's the thing that would matter later. HIP 65426b was already known. It had been discovered back in 2017 by a telescope in Chile. Webb didn't find it. Webb just took the clearest look yet, which left one enormous question hanging in the air. Could this telescope ever find a planet nobody knew was there? Not by measuring a shadow, not by following someone else's coordinates, but purely by seeing it? That question sat unanswered for almost 3 years. To understand why that was so hard, you have to understand the wall it kept hitting. Every planet we'd ever directly imaged had one thing in common. They were monsters, massive, hot, and glowing. Because young giant planets radiate the leftover heat of their formation as infrared light. This telescope sees in infrared. So a hot young giant is the easiest possible target. But the planets we actually care about, the ones like Saturn, Neptune, and eventually Earth, are smaller, colder, dimmer. And every step down in size makes the planet dramatically harder to see against the glare. For years, the smallest planet anyone had directly photographed was still comfortably bigger than Jupiter. Everything below that, invisible, out of reach. That was the wall. But that's not even the strangest part of this story, because the target that would finally break the wall wasn't chosen for its planet at all. It was chosen for its dust. There's a star called TWA-7. It sits about 111 light years away. And it is young, absurdly young, around 6 million years old. To put that in perspective, if our 4.5 billion-year-old solar system were a middle-aged adult, TWA-7 would be a newborn still in the delivery room. And around this infant star is a disk, a vast, faint ring of debris, dust and rubble and the raw material that planets are built from, spread out in a broad, flat halo. Astronomers already knew about the disk. They'd seen it from the ground, and they'd noticed something peculiar about it. The disk wasn't smooth. It was carved into distinct rings, with gaps between them, empty lanes, dark corridors swept almost clean of dust. Now, here's where it starts to get interesting. In a system that young, gaps like that don't just appear on their own, something has to carve them. And here's where it stops being a story about dust. Because for decades, theorists had predicted a specific, almost eerie phenomenon. When a planet forms inside a debris disk, it doesn't sit there quietly. Its gravity acts like a snowplow. It sweeps up the dust and rubble in its orbital path, clearing a gap, a dark, empty lane in the disk that traces the planet's own orbit. So when astronomers look at a young star and see a suspiciously clean gap in its dust, they start to wonder what's hiding in it. For years, that was just a theory, a prediction on paper, beautiful, elegant, and unproven, because the thing supposedly carving the gap was almost always too small and too faint to actually see. You could see the footprint, never the foot. TWA-7 had exactly that kind of footprint. 3 rings, and 1 narrow gap bounded by 2 nearly empty lanes, which meant the team pointing this telescope at the star weren't just taking a picture of a disk, they were checking the gap. They were looking for whatever was standing in it. In June 2024, the James Webb Space Telescope turned its mid-infrared instrument toward TWA-7. They used the coronagraph, blocked the star, killed the glare, and then they did something painstaking. They subtracted the star's light out of the image entirely, digitally, pixel by pixel, until the center of the frame went dark and only the faint surroundings remained. And in that darkness, right inside the gap the theory said a planet should be carving, there was a spot, a single faint source of infrared light, sitting almost exactly where a planet was predicted to be. The team said the object showed up exactly where they expected to find a planet shaping the disk. Now, stop for a second. Because your instinct right now is probably the same as theirs was. One faint dot? That could be anything. And that is precisely the doubt that nearly ended this discovery before it began. Here's the trap that catches astronomers over and over again. The universe is full of things that look like nearby planets, but aren't. The most dangerous imposter is a background galaxy. A distant galaxy, billions of light years away, can smear a little blob of infrared light right onto your image, sitting, by pure coincidence, in the exact patch of sky where you are hoping to find a planet. Get fooled by one, and you don't discover a world. You embarrass yourself in a journal. So the team had to ask the brutal question, what are the odds this faint dot is just an unlucky background galaxy pretending to be a planet? They ran the numbers, and the answer came back, roughly a 0.34% chance. Let that land. About 1 in 300. 99.66% of the evidence pointed one way. But very likely, a planet is not the same as a planet. And scientists, real ones, live in that gap between very likely and certain. So they needed more than a dot in the right place. They needed the dot to behave like a planet. So the team did something clever. They built a simulation. A model of a young star wrapped in a dusty disk, with a planet of a specific mass placed inside that gap. Then they let the physics run. The gravity, the sweeping, the way such a planet would shape the dust around it. And they asked a simple question. If a planet like this were really there, what would this telescope actually see? They generated a synthetic image, a prediction of what the data should look like if the dot was a real world of the right mass. And then they laid it next to the real image. They matched. The simulated planet carving the simulated gap produced almost exactly the pattern the telescope had captured for real. The lead author later said this was the moment they were confident. This is why they believed there was a planet there at all. The footprint, the foot. And now, the physics tying them together. But that's not even the part that stunned people. The part that stunned people was the number. Because when they worked out the mass of this thing, it wasn't a super Jupiter. It wasn't a monster. It came out at roughly the mass of Saturn, around 1/3 the mass of Jupiter, Some described it as being in Neptune's weight class, and in the world of direct imaging, that is almost heresy. Remember the wall? Every planet ever directly photographed had been a giant, several times Jupiter's mass or more. That was the floor. Nobody had ever pulled a Saturn-mass world directly out of the glare next to its star. This planet, now named TWA-7b, was about 10 times lighter than any exoplanet that had ever been directly imaged before it. 10 times lighter than the previous record. The wall didn't just crack, it moved. And it gets stranger because this world doesn't sit where you'd expect a planet to sit. TWA-7b orbits its star at a staggering distance, roughly 50 times farther from its sun than Earth is from ours. More than 5 times farther out than Saturn sits in our own solar system. It's a Saturn-mass world flung out into the deep, cold suburbs of its system, plowing a lonely gap through a ring of dust. And it is warm, but not the way you'd hope. Its temperature is estimated at around 120 degrees Fahrenheit, not from sunlight, out there in the dark, from the leftover heat of being newly born. Because remember, this entire system is barely 6 million years old. We are, quite literally, watching the youth of a planetary system, catching a world in the act of forming, while the dust that built it is still swirling around it. We are looking at a snapshot of how solar systems, maybe even our own, begin. But the real significance of TWA-7b isn't its size, or its orbit, or its youth. It's how it was found. Here's the thing every earlier planet image from this telescope had in common, including that first one, HIP 65426b, back in 2022. Those planets were already known, discovered by other telescopes years earlier. Webb was handed the coordinates, it just took a sharper picture. TWA-7b was different. When the team published their results in the journal Nature on June 25, 2025, they were announcing something this telescope had never done in its entire existence. For the first time, the James Webb Space Telescope hadn't confirmed someone else's discovery. It had made its own. The very act of capturing the image was the discovery. The planet was unknown until Webb saw it. Nobody flew there. Nobody detected its shadow. Nobody predicted the exact object. A telescope simply looked into the dark beside a star and found a world that no human had ever known was there. The lightest planet ever seen this way. The first planet this telescope ever discovered by seeing it. And that changes what comes next. Because if it can pull a Saturn-mass world out of the glare, then the question everyone in that field is now quietly asking is a much bigger and much stranger one. How much smaller can we go? Because there's a line on that scale. A size where another gas giant becomes something far more haunting. The size of a rocky world. The size of Earth. And to understand whether we're anywhere near crossing that line, we have to be honest about what this discovery does and what it doesn't prove. Let's separate what we know from what we're hoping. Here's what is known, confirmed, and published. This telescope photographed a Saturn-mass planet directly. It was the lightest world ever imaged this way. It was its first true direct imaging discovery, and it sits inside a debris disk, carving a gap, exactly as decades of theory predicted a planet should. That last part matters more than it sounds. For years, the idea that unseen planets sculpt the rings and gaps in these disks was a well-supported theory, but you were always inferring the sculptor from the sculpture. TWA-7b is one of the cleanest cases where we may be seeing the artist standing next to the art. Now, here is where I have to be careful with you, because this is where a lot of channels start lying. Speculation begins here, and I'll tell you exactly when it ends. TWA-7b is not a second Earth. It's a giant, distant, freshly formed world, far too big and far too cold and far too young for anything we'd recognize as life. Nobody serious is claiming otherwise. But the technique is the story. Every time we've imaged a smaller, dimmer planet, we've proven our instruments can dig deeper into the glare than the time before. Super Jupiters, then Saturn-mass worlds. The trend line only points one direction. Some scientists believe that the next generation of instruments, enormous ground-based telescopes now being built, and space observatories still on the drawing board decades out, could eventually push this same technique down toward Earth-sized, rocky worlds around nearby stars. If that ever happens, and no one can say for certain that it will or when, it would mean doing to a pale blue dot what this telescope just did to TWA-7b, pulling the faint reflected light of another Earth out of the blinding glare of its sun, not inferring it. Seeing it. And on that day, the question stops being, is there another Earth out there? It becomes, which pixel is it? Speculation ends. Back to what's real. We are not there yet. Not close. But the reason a small, faint dot next to a young star made headlines around the world isn't the dot. It's the direction the dot points. For most of human history, the other worlds were rumors, points of inference, shadows behind a spotlight. And now, one at a time, we are starting to turn the spotlights off and look the neighbors in the face. Remember what I told you at the very start. A world that, until recently, no human knew existed. No probe flew past it. no spacecraft ever will? We found it not by watching it dim a star, but because a telescope, for the first time, simply looked and saw it looking back. That's TWA 7b, not the biggest planet this telescope has ever seen, not the most beautiful, but maybe the most important, because it's the first one it found on its own and the smallest we've ever dragged out of the light. It's a doorway, and it's barely cracked open. If this shifted the way you see the night sky even a little, if you're now looking up and wondering how many faces are hiding in all that glare, do two things. Subscribe and turn on the bell. Because the next discoveries in this exact story, the smaller worlds, the colder ones, the ones that start to look uncomfortably familiar, are coming. And when they land, this is where they'll be explained first, honestly, without the fake panic. And if you want to understand the real endgame here, how astronomers plan to actually photograph a rocky, Earth-like world around another star, and why some of them think it could happen within our lifetimes, watch this next. Because TWA 7b was the proof of concept. The real target is still out there in the dark, and we are learning, one planet at a time, how to see it.